You're reviewing structural drawings, and you see callouts for M25 concrete for the slab, M30 for the columns, and M40 for the shear walls. These aren't just arbitrary numbers. They are the most critical specification for the material that forms the skeleton of your building. But what do these grades actually mean? How is M30 different from M25? And why does it matter? Using the wrong grade is like building a bridge with the wrong steel. It might look right, but it's a disaster waiting to happen. In this video, we're cracking the code on concrete grades. We'll explain the science behind the numbers, how these mixes are designed, and the precise logic that determines which grade goes where in a structure. By then, you'll be able to read a concrete grade and instantly understand its strength, its composition, and its perfect application, ensuring your projects are safe, efficient, and built to last. Let's start with the most important concept, characteristic compressive strength. This is what the M number represents. The M stands for mix, and the number following it is the characteristic compressive strength of a 150 mm concrete cube after 28 days of curing, measured in megapascals MPa. So, M25 concrete has a characteristic compressive strength of 25 megapascals. But what does characteristic mean? In engineering, it doesn't mean the average strength. It is defined as the strength below which not more than 5% of the test results are expected to fall. In simple terms, if we test 100 concrete cubes made from M25 concrete, we expect at least 95 of them to have a strength of 25 MPa or higher. This built-in safety margin is crucial for reliable structural design. The 28-day period is standard because concrete gains strength rapidly initially but continues to hydrate and harden for years. 28 days is the accepted benchmark for when it has achieved a substantial portion of its design strength. A pro tip for site engineers is to also pay attention to the 7-day test results, as they can give an early indication of potential strength issues and allow for corrective action before the 28-day mark. Now, how do we achieve this specified strength? This is where mix design comes in. And it's split into two philosophies, nominal mix and design mix. The nominal mix is a prescriptive, volumetric approach, like the classic 1:2:0 for mix 1 part cement, 2 parts sand, 4 parts aggregate. This was common in the past and is still used for small, non-structural projects. However, it's inefficient and inconsistent because it doesn't account for the moisture content, absorption, and shape of the local aggregates. The modern, professional standard is the design mix. This is a performance-based approach where a civil engineer designs the mix in a lab to achieve the specified grade, e.g., M30, using the specific materials available on the project. They determine the exact proportions of cement, water, fine aggregate, coarse aggregate, and often chemical admixtures to achieve the required strength, workability, and durability most economically. A common and costly on-site mistake is to add excess water to a design mix to improve workability. This drastically increases the water-cement ratio, permanently reducing the final strength and compromising the entire design. So, which grade should you use where? The selection is a careful balance of structural requirements, durability, and cost. For simple foundations and blinding layers, M15 or M20 is often sufficient, as the loads are distributed over a large area. For reinforced concrete elements in typical residential and commercial buildings, like slabs, beams, and columns, M25 to M35 is the standard range. M25 is a very common all-rounder for slabs and beams, while M30 or M35 might be specified for more heavily loaded columns in the lower floors of a multi-story building. When we move into high-rise construction or specialized structures like bridges, we enter the realm of high-strength concrete HSC, from M40 up to M60 and beyond. This concrete uses specialized cements, high-quality aggregates, and powerful superplasticizers to achieve incredible strength, allowing for slimmer columns and greater heights. For pre-stressed concrete elements like beams and hollow-core slabs, high early strength is critical, so grades from M35 to M50 are typical. The efficient workflow secret is that the structural engineer's calculations determine the required grade. It's not a random choice but a direct output of the analyzed stresses in each member. It's also vital to understand that strength is not the only property that matters. Durability is equally important, especially in harsh environments. A marine structure or a bridge deck exposed to de-icing salts might specify an M40 grade not just for its strength, but because the denser, less permeable microstructure of high-strength concrete better resists chloride ingress and sulfate attack. This is where other specifications, like the minimum cement content and the maximum water-cement ratio, come into play alongside the grade itself. Furthermore, we have specialized grades like self-compacting concrete SCC, which can be designed to any grade, e.g. M30 SCC, but has the added property of flowing and consolidating under its own weight. Perfect for highly congested reinforcement. To summarize the key takeaways: 1. The concrete grade, e.g. M25, specifies its characteristic compressive strength in MP at 28 days. 2. Modern construction relies on design mixes for precise, economical, and consistent quality, not outdated nominal mixes. 3. Grade selection is structural, M25, M35 for general RCC, and M40 plus for high-rises and specialized applications. And 4. The grade is often linked to durability requirements, not just pure strength. Now I want to hear from you. In the comments below, what is the highest concrete grade you've ever specified or worked with on a project? What was the application? And what were the biggest challenges in producing, placing, or testing it? Your experiences with real-world mixes are invaluable. If this guide to concrete grades has helped solidify your understanding, please give this video a like and subscribe.